So we started discussing about how to configure router, initial configuration of router. Cisco IOS version, Cisco IOS modes like user mode, privilege mode, global configuration mode, and initial configuration, like basic task also have discussed. So today we'll continue with WAN technologies. Simple thing is how to connect to different offices, to different locations, like one organization, one location, another site is another location. How to connect it? This example. Yeah, branch office 1, Chennai. Branch office 2, Bangalore. So to connect to different sites, we require technology called what? WAN technologies. Types of network access. Enterprise access, internet access. Types of WAN technologies are two different types. Enterprise access, internet access. In enterprise access, like generally companies will use, like organization to organization, they can, like banking sectors, government sectors, you know, IT companies, they use enterprise network. Internet access means generally what we are using internet, that is a general internet. Enterprise, we can say almost is a private network. In enterprise network access, again, we have different type of technologies. Dedicated technology, switched network, VPN, like a lease line, ISDN, PSTN, frame relay, MPLS. These all are different type of technologies in switched network. In VPN, GRE VPN, IPsec VPN. So different types of VPN, DM VPN, SSL. Similarly, in internet also, these all are different types of technologies we have. So today we are started discussing about point number 1, WAN technology. See, what is the major differences between lease lines and a broadband? Example, this is your network. It's your office network or home network, whatever. This is your network. And if you need internet connection, we contact a service provider. So your network is in Hyderabad, area is Amirpet, road number 5. So here I need internet access actually. And contact to service provider. So service provider are in different location. So ISP will provide internet all over city wide, right? And ISP will give one internet cable. That cable is directly connected to a customer? No.
No.
So customer, all devices are connected to Wi-Fi router, right? Through wired or wireless. Where exactly you required internet? At which location? In Amirpet, road number 5. In Amirpet, road number 5, I am only the customer and many customers will be there.
Mm.
Many customers. So what ISP will do? ISP will install one network switch nearby road number 5. From this, like a similar to switch actually, from this device, they can distribute to all customers. Like there are customer A, I'm a customer B, and customer C. Like from this switch, all customers are connected. Many customers are connected. From ISP switch to ISP office, ISP maintain optical fiber cables. See, so OFC. Got it? This is the connectivity, guys. But what type of technology are you using? Are you using broadband or using laser line? Example, it's the broadband. Broadband, as per your plans, internet plan, say I'm getting 16 Mbps plan. If you're getting 16 Mbps means, do you think always I'll get the 16 Mbps?
No.
No, up to 16 Mbps. So sometimes we can see 10 Mbps, sometimes you can see 5 Mbps, sometimes you can see 16 Mbps also. So in generally, in broadband, there is no fixed bandwidth.
Yes.
Agree?
Agreed, sir.
No fixed bandwidth. Have you experienced like sometimes you'll get internet is faster. So sometimes internet is very slow. Anyone have experienced this like this?
Yes, sir. And broadband.
Yes. Generally we used to experience like that only. So sometimes we can see very fast internet. Without buffering we can, and sometimes is buffering because of broadband it is not fixed bandwidth. Next point number two, customer A connected to ISP switch. Customer B connect to same switch. Customer C connect to same switch. So means customer A traffic is going via switch. Customer B traffic also. Customer C traffic also. Like all customers traffic is going via the same device. So any one customer can capture the other customer's traffic. They can be monitored. So let's say I'm a customer C. So what customer C will do? Whatever the traffic is going via switch, I can capture it. Customer A traffic, customer B traffic, I can capture it. Correct?
Yes, sir.
Yeah. So seems less security because of all customers traffic is going the same device. The next point is what if you have your optical fiber cable is down, cable which is coming to your area, it is failed, means no internet access. Then you call to service provider. So I'm not getting internet. Then what service provider will do? Sorry for inconvenience. So optical fiber cable is down at your area. My team is working on it. It may take 4 hours time. You got a message. You have waited for 4 hours. Still is not getting internet. Again you call back to ISP. So ISP will say what? Still my team is working on the same. It may take 1 day or 2 days. What we'll do now? Can we do anything? Can we demand ISP? No, I need internet connection now, right away. Can we demand it? No. So means a downtime can be any. We can't say exactly the downtime. So there is possibilities of more downtime. So these are the common issues we can face in broadband. No fixed bandwidth, less security, more downtime. But the good thing in broadband is you'll get internet for very cheaper price. Very less price you'll get internet actually. Agree? For 500 rupees also you're getting internet. Broadband connection. Less, very less price. If it is a home network, then it's okay. Broadband is okay. What if it is my organization, is my office, is enterprise network? Like many engineers are working here actually. A project is working here. A product is developing here. It's a corporate network. So for corporate networks, do you recommend to use this type of technology broadband?
No.
No, because of the all your engineers will be face no fixed bandwidth, sometimes faster communication, sometimes slow communication. Should not be like that now. Less secured, more downtime. No. Then you can ask the service provider, so we don't require this type of technology or network should be bandwidth should be fixed. Then ISP will offer, okay, you take another technology called lease line. Then if you take a lease line from service provider, the service provider will give a separate link from ISP to customer directly. Separate link. Dedicate a link for ISP to customer action. Say this link is 10 Mbps link. Technology is what? Lease line. So lease line technology, point number one is 10 Mbps, right? If it's 10 Mbps, then bandwidth is fixed. Always will get 10 Mbps. Fixed bandwidth. Means your data communication is, your bandwidth is consistent, right? Yeah. So based upon the speed, you can run the programming. Your engineers can come to know, okay, now bandwidth is stable, consistency will be there. We can run some program, fixed bandwidth. At any time, they'll get 10 Mbps zone. Is there any chance other customers can monitor our traffic now? No, because we have dedicated separate link. So via this link, only our customers' traffic only will be moved, no other customers' traffic. It's high secured, almost is like private network. Because of other customers' traffic is not involved here, high secure. Thing is, ISP and customer will have an agreement. We call it is SLA, service level agreement. For lease lines, they'll give one agreement actually. What ISP will say? ISP is promising to customer, your network downtime is less than 1% downtime. Less than 1% downtime means almost no downtime actually. That's the agreement. So whatever the technology we are providing, this technology, these links will be never down. If it is downtime also, it will be less than 1% only. That is promising. It's a giving agreement actually. That we call service level agreement. And agreement is what? Your bandwidth is fixed. If it's 10 Mbps, always 10 Mbps. It's 20 Mbps, always 20 Mbps. And other customers will not involve. We have a dedicated line for you only. So customer and ISP is making one agreement. We call it is what? SLA, service level agreement. And almost no downtime. So which is the best for corporate companies? Point
Yes.
is, compared to broadband, lease lines are very high price. Monthly, you'll get 1 lakh, 1.5 lakh, 2 lakhs bill actually for lease lines. Got it? So these all are differences between lease line and broadband. So for home-based network, broadband is good enough. For enterprises and commercial network, we'll go with lease line. Any doubts? Okay.
Hi, sir.
Yes.
Uh, Like in the laser line, is there any specific number of systems we need to connect it is
No, no, no. Any number of like more systems you can connect. There is no specific number. Like we need to connect only 10 computers or 100 computers or 200 computers. It can be n number of devices we can connect actually.
so all systems will get the same speed, okay, which as per agreement.
Yeah. Okay. Point number two, WAN topologies. WAN technology is okay. Laser line, we decided, is the best for corporate companies. Then how to design these topologies? This is your head office. Branch 1, branch 2, branch 3. Head office connected to branch 1. Head office connected to branch 2. Head office connected to branch 3. So which technology we used? Laser line. So from head office, serial port 0, connect to branch 1. Head office serial port means WAN port connected to branch 2. Head office serial port connect to branch 3. Like this. So multiple branches, all branches are connected to head office. This type of topology is we called star topology. Star. Or we can call hub and spoke topology. Hub and spoke. Like all branches are spokes. Hub is head office is hub. So the good thing in hub and spoke topology is less number of connections. How many laser lines are required here to connect these four branches? Laser line 1, laser line 2, laser line 3. How many laser lines? 3. So less number of connections. Easy to implementation. Deployment is very simple. So this type of topology we call star topology or hub and spoke topology. Like multiple branches are connected to one centralized branch. So point is, how exactly your branch office 1 and branch office 2 can communicate? So branch 1 traffic will come to head office and head office to branch 2. Like all spokes can talk each other via head office only, via hub only. Agree? So what if link between head office and branch 1 got failed? Link between head office and branch 1 got failed. Then how branch 1 and head office can communicate? How branch 1, branch 2 can communicate? Branch 1, branch 3 can communicate? No communication. So we call it a single point of failure. If link is down, then no communication. No backup, no redundancy here. So there is a problem in hub and spoke topology. So to overcome this type of issue, because we require a redundancy purpose, I'm connecting one more laser line from branch 1 to branch 2, branch 2 to branch 3, branch 1 to branch 3. Like each branch connect to each other. So this type of topology we call full mesh topology. Full mesh. So after full mesh topology, even link between branch 1 head office failed also, still they can communicate, right? Via branch 1 to 2 to head office. Or if it is one more link is failed also, branch 1 to 3, 3 to head office. Like more redundancy, more backup. Full redundancy is available. So which is the best one? Hub and spoke topology or full mesh topology? Yes. Fluffy following me?
Yes, sir.
So in full mesh topology, we required more number of connections. Like lazy line 1, lazy line 2, lazy line 3, lazy line 4, lazy line 5, lazy line 6, 6 lazy lines. More number of connections. Is also one of the drawback, more complexity. Star or we called hub and spoke topology, easy to deploy, less number of connections, no backup, no redundancy. Full mesh topology, all branches interconnected with full redundancy, but more connections, complex configuration. So what we can do, we can design like this, like a mix of these both topologies. We call is partial mesh. Actually, we require redundancy, but we don't require multiple redundancies. Already you are using lazy lines. Lazy lines is less than 1% downtime. Then why we require a multiple backup links? Because each lazy line is very high expensive. And if you have the more lazy lines, it's complex creating now. So one backup is enough. It is partial mesh. Mix of both topologies. Now, point number 3, continue with WAN connectivity, like how to lease lines are connected, what type of equipment is involved, how they are connected exactly. Let us see. Okay. So WAN connectivity require two types of connections. Point number 3, WAN connectivity. What is point number 1? Point number 1 is WAN technologies. Point number 2, WAN topologies. Now point number 3 is WAN connectivity. So to connect these two branches, we must require two type of connectivities. One is physical connectivity and logical connectivity. So branch 1 and branch 2, to connect this both, we must require two type of connectivities. One is physical and logical. So physical connection means in physical connectivity required cables, modem, devices. These things are required. And point number 2, logical connectivity. IP address, protocols, like this. So first let us discuss about physical connectivity between these two sites. Physical connection means cables are required. Can we make one cable from Chennai office to Bangalore office directly? No. So we'll contact a local service provider. Like Chennai office, we need to contact a local service provider. Bangalore office, they will contact a local service provider. ISPs will maintain the link actually. Because ISPs have the cabling part all over India wide and worldwide. They have a cabling part. They will manage. So we need to ask a line for 1 year or 2 years. So taking a line for lease, we call lease line. So if we contact a service provider will maintain some devices to provide the lease line. That device we call MUX. So I'm explaining a traditional lease line mechanism actually. Okay. They maintain some device called what? MUX. In other side also, in Bangalore office also maintain devices called MUX multiplexes. From MUX they'll distribute the cables actually. From MUX it is connected to modem signal converter. Modem to router. This modem name is CSU-DSU modem. Channel service unit, data service unit. CSU-DSU modem to serial port and it connected to MUX. And MUX to MUX ISPs will maintain the cable, optical fiber cable. Okay. So this is the connectivity, guys. So for lease lines, equipment is modems, MUX, optical fiber cable, copper cable, all the required. This is a clear diagram between two offices, Chennai office and Hyderabad office. Yeah, this is a full picture. Now equipment have two types of devices here, like a data communication equipment, which is CSU DSU modem. It's a master to generate the clocking, and data termination equipment is accept the clocking, called a slave, master and slave devices. So the device which generate the bandwidth, the device we call master device. The device which accept the bandwidth, accept the clocking, we call it is slave. ISP is a master, customer is a slave. Like that we can understand simply. Okay. But what if devices are in short distance? If distance between two devices is short, like in one rack, two routers are available, then how to connect? So if distance between two routers is short, then you can use this cable, like back-to-back serial cable. So when distance between two routers is short, a special V35 back-to-back cable used to replace your copper wire, mux, modem, these all are not required. These are the equipment required for different locations. One of is in one location, another of is in another. Then this equipment is required. What if distance between two short is? You can use this cable, back-to-back cable, for data communication purpose using back-to-back cable. It is clearly printed on the cable, right? One end is the DCE, other end is DTE. DCE end is a master. You need to generate the clocking. DT end is slave. It will accept it actually. So any doubts in physical connection, guys? So physical two devices are connected like this. If distance between two routers in the distance, like one is in one side, another side, then release the line, mux, modem, everything. If it is a short, then you can use back-to-back cable. DC end, we need to generate a clock. DT end, it will accept it. That you remember. Okay. Then logical connection means IP address and protocol. Rule is, to take example of this, a back-to-back connected. Branch office one serial interface IP address and branch office two serial interface IP address. Both should be in same network because both are back-to-back connected, right? So serial 0/0 of branch one interface IP, 0/1 interface, both are back-to-back connected. This both interface IP address should be in same network. This is the rule. Okay. If 172.16.0.1 I configured, other end should be in same network. 172.16.0.2 like. The next point is we know how to assign IP address to WAN port, right? Interface serial 0/0, IP space address, subnet mask, and to activate no shutdown. Once if we configured, data packet is being generated. We'll come to fast Ethernet. Fast Ethernet will send the traffic to serial port. What serial port will do? Packet forwarding. Before forwarding packet, the serial ports will add some headers to the data packet. Anyone remember what we call this process adding headers to data?
Key heading.
Encapsulation. So here, WAN interface encapsulation process. WAN encapsulations are two different type of protocols we have. One is triple P, point-to-point protocol, and HDLC, HDLC, high-level data link control. So difference between a point-to-point protocol HDLC is if R1 router is a Cisco router, R2 also Cisco router. So on every Cisco router, HDLC protocol is enabled by default. So HDLC protocol works in only Cisco. It's a Cisco proprietary protocol. If it is a Cisco device, it will add HDLC headers. We no need to be configure also because HDLC works in Cisco routers by default. Like one end is a Cisco, other end is a non-Cisco, like other vendor you are connected, then HDLC will not work now. We required one open standard protocol which works in Cisco and non-Cisco. So point-to-point protocol is open standard protocol. It works in the both. We can configure point-to-point protocol in Cisco and non-Cisco also. But point-to-point protocol supports for authentication. Point-to-point protocol supports for compression mechanism. Whereas HDLC protocol, no authentication mechanism, no compression mechanism. Is the difference between point-to-point and HDLC. Okay. Yeah. One end if we configure HDLC, other end must be configured HDLC. One end if we configure point-to-point protocol, other end must be configured point-to-point protocol. So this encapsulation must match on both ends. One end if you configure HDLC, other end is point-to-point protocol, no, the link will not come up, it will be down. Because point-to-point protocol authentication, so one end is a point-to-point protocol, other end if you configure HDLC, whenever traffic is coming from HDLC, what point-to-point protocol will say? So I don't want to trust you because you are not a non-authenticated protocol. How we can trust? Like, but the thing is, both sides protocol should be matched. Encapsulation is a process of adding a new header or trailer to the data. Headers and trailers contain information which is needed for proper transportation of the data to different type of WAN encapsulation, triple P and HDLC. Got it?
Yes, sir.
And what is the difference between point-to-point protocol and HDLC? There's a difference. Point-to-point protocol, open standard, supports authentication, supports compression. But HDLC, vendor proprietary, means Cisco proprietary protocol, no support for authentication, no support for compression. Right? So to identify whether that interface is DCE or DTE, you can use this command. Show controller serial and port number. And configuration is this.
Your voice is not clear.
Hello? Hear me?
Yes, sir.
Okay.
Yes, sir.
I'll show you the practical. First, let me share the commands for WAN interface configuration. Yeah, done. See, first out I'm using 2621. Next 2811. Next 2621. Now between two routers, what type of connections we need to use, what type of cable? Serial port to serial port, DCE cable. Connections, if we see here, serial DCE cable, clock symbol showing, right? This cable you can use between router to router. Take this router and click on router. What are the ports are available? Auxiliary port, console port, fast Ethernet 00, fast Ethernet 01. But it's not showing the serial ports because by default we don't have a slots. Serial slots are not available. We need to add that module action. How to add? Click on router. See, this is slots are empty. These blocks are empty, right? Here you can see modules, like many different type of modules we have. Choose the second last one, WIC2T. Drag it and drop here. Before drag and drop, your router power should be off. Drag it and drop. And power on. CLI. Like this and second router also. Since second router it is 28 series, right? 2811. Here we can see many slots. 1, 2, 3, 4 slots are available. In 26, only 2 slots are like this. Here also second last. Last order also is 2611 now. Here we can see 2 slots only. Drag it and drop. Oh, see this error message. Cannot add a module when the power is on. Your power should be off. Power on. Now use a serial cable. Click on first router. So now you'll get serial port, right? So serial 001 and other end 001. 00 also can connect. My example, I'm using 001. Again, 000 001. Done. The configuration. See, remaining connections you need to make it like router to switch, switch to 3 computers. Okay. Skip it. First point is host name, branch office 1. Now for branch office 1, if we use this command show IP interface brief, you can get your router's interface's status information. Fast Ethernet port 00, IP address unassigned, status administratively down, protocol down. Even serial port 00 also unassigned, administratively down. Like we need to configure it. Let us configure serial port 00. So first you configure fast Ethernet, then come to serial port. But here now I'm slightly right away configuring serial port. Interface serial 0/0, IP space address. What is our example? 172.16.0.1. 172.16.0.1. 255.55.0.0. No shutdown. Encapsulation. Triple P. Clock rate. If it's a DCN, we need to generate the clocking rate, right? So how much value you need to set the clock rate? If you don't know how much you can support, clock space, rate space, if you use question mark, it shows the list of speed. Minimum speed and maximum speed. From this list, you can choose anyone. Choose clock rate from this above list actually. Default I'm using 64,000. 64,000. Done. You can exit. So I repeat the configuration. Interface serial 00, IP address, no shutdown, clock rate, encapsulation, right. So one end I configured and encapsulation is what? Triple P. Other end also must be triple P actually. Point to point protocol. Let me take router 2. See, if you configure only one end, your LED still it is a red. In both ends, if you configure, then it will come to green. Skip it. Config T means config terminal. Host name. Head office. Interface serial 0/0/1. IP address 172.16.0.2. 255.255.00. No shutdown. So yesterday I clearly explained about this up message. Always we must get how many times up message? 2. This interface is up, but we didn't get protocol is up, right? When protocol will up, encapsulation should be matched on the both sides. So one end we configured encapsulation is triple P. Here also encapsulation space triple P. Yeah. Now we got protocol is also up message. You can see here it is becoming green now. One end, another end, both sides. Again, if you check the status from branch 1 to branch 2, IP assigned, status is up, protocol is up. And you can use ping command 172.16.0.2. Enter. Success rate is 100%. Like this, we can configure WAN interface. Okay. Doubts. Yeah. All right. So you also try to practice on the three routers. If you have any doubts in today's practical, you just keep posting on a group. Wherever you're blocking, take a screenshot and post in the group. I'll try to help you out. Okay.
Sir, this is Srikanth. Could you please add me in the group? Actually, I was joined today class.
Anyone, can you share the link?
Sir, I want a link. I'm not having it.
Yeah, yeah. Wait, just a wait. Someone can share a link here actually. Then using that link, you can add. No, not responding. Shyam, Rajkumar, Srikanth, Tarun, Dia, Akit. Anyone, please share, man. Like I'm connected through laptop now. Or wait, then who is on the group now? Yeah, I have shared the link in group in chat. You can use this link to join in the group. Okay.
Thank you, sir. I am joining.
Yeah. Thank you.
Sir, could you please share, if possible, to last lab 1 and lab 2 configuration?
File
If possible.
configuration. Lab one don't have configuration.
Okay.
Initial configuration we have. Initial configuration. Oh, I have shared in group actually.
Yes.
Are in group. Right. Okay, guys. So try to practice on this today. Okay. Bye.